Thank you very much, DataRobot, for having me here. Thanks for you guys for your attention here. I want to shift the discussion a little bit to how we actually do it, in a real customer company. So I'm the Chief AI Officer for Oxy, one of the oil majors here in the U.S., and you might have heard of us as Warren Buffett's oil company. So that's where we fit into the economy. Ultimately, it's a physical business. It's an asset-heavy business. So what business do we have doing AI? Well, it's actually used in every single part of what we do. And I want to talk to you mostly about the 3 leading causes of death for AI. Okay, to start off on a really positive foot. So the number one reason why most AI projects fail is because ultimately the human users, the human stakeholders say no thanks for a variety of reasons. The second is that the users say, yes, please, I want this, but you've made the software so clunky to use that I can't. And the third is you've solved a problem nobody has. Right? You've either solved a special case of it, you solved a different version of it, you misunderstood what the customer wanted in the first place. Between those 3, and this is a well-validated thing, this isn't Patrick's opinion, you can go to any of the major consulting companies and read reports on LinkedIn about this. Those are the 3 reasons why AI projects fail. They do not fail because the math doesn't work. They do not fail because the software doesn't work. It's not a technology problem. It's generally a human problem. So that's what I want to focus on when we create these agents. So the first thing is really to be very clear about what the task is. So you've heard, somebody's built an agent here to order butter, sugar, flour. But apart from the obvious thing of ordering these things and making sure they come, what's the task involved, right? What do you actually want? Do you want your inventory to always be at 100%? Or do you want it to be at 50? Do you have to react to certain special events by having a larger inventory in front of Easter or something along those lines? I don't know, I don't run a bakery. But you have to define what exactly the problem is for the agent to be able to solve it. And that's ultimately something that is a collaborative process between a variety of people. You're all familiar with the parable of several blind people, touching the elephant. Each person touches a different part of the elephant. Nobody realizes that they have an elephant in front of them until they have a conversation. It's the exact same thing for us here, right? In that bakery example, unless the owner of the bakery, the baker, and ultimately perhaps a selection of customers talk to each other about what it is that they finally expect to get, you'll make a great agent, but that agent will fail. Beyond that, of course, we've heard costs discussed here, right? So it's a question of prioritization. So at our company, we currently run over 200 use cases or agent cases simultaneously right now. We have a wish list of another 400 or so that different people are asking us to work on. So essentially, we have an unlimited mountain of work ahead of us in the AI department. And so the choice is, which agent do you build first? You can only build so many simultaneously, right? And then you want to move on to the next and move on to the next. And if you tell people, well, it's your turn in 2028, not a popular thing to say. So a prioritization framework is necessary. We chose this one. It's by Gartner, where essentially you evaluate where in the business do you go? Are you front office, back office? Are you a support function? And ultimately you assess 2 things. How much value do you provide to the business and how feasible is it to do? So there are certain cases that are effectively a scientific moonshot. At the beginning, we really don't know if we're able to solve that problem. Maybe we don't have enough data to represent the problem correctly, in which case agents would have a hard time. Or there is some kind of a mathematical challenge in there and we really don't know if AI can handle it. There are other cases where it's a complete no-brainer because a bunch of our competitors or other companies have already done that. And so the feasibility is at 100%. And then we're asking about value. So we've got plenty of cases where if you make a one-time investment of X, you then have a year-on-year return of 20X. It's a no-brainer. You do that, right? There's actually plenty of examples in asset-heavy industries where that's true. And so AI is well worth it, but you still have to compare the cases. So having an overview diagram like that is super useful in looking at a portfolio where you're not building one or two agents, but like we're doing hundreds of them. Then it's a team sport. AI agents are not built by the AI team alone. We need a variety of other players to help us along the way. And so I'm saying, like, we play defense, but we need a goalie, and we need the offense, and we need the managers and so on around. So I represent the community of data scientists, AI engineers, but our domain experts, again, coming back to the bakery example that we heard, right? That would be the people who actually know how to do that stuff. We need to talk to them and learn what the problems are, what the processes are, how you bake the bread in order to make all this stuff happen. And then, of course, we need management to supply the necessary resources to help prioritize what's important to you. And ultimately, the most important constituency here are the customers, the users, the people who are going to actually interact with this agent and make it happen for real. And they're the one that really represent, as I said, the major risk, because the two leading causes of death are either the users not wanting to use the agent or not being able to use the agent, right? So that's your major risk factor. Then we talked about, how do I actually get to the point where this is working? So Prajakta said, what was it? It's not the vision that's hard to buy into. It's when you get to the deployment. That's right? The vision is easy. All over social media, it's like, AI agents and whatnot, but like, okay, so now how do I make them actually work in real life? You're all familiar with agile project management. This is my scientifically called bubble chart that makes it visible for management, again, over a portfolio of hundreds of these things. Where are we? So you can see that we have a stage-gated process of going from we have no idea what we're doing, settling with stakeholders, what's the task at hand, all the way to full-on production. And there's a sort of rough timeline indicated how long this stuff ought to take. And a lot of people in our industry, not the oil and gas, the AI industry, right? A lot of us AI people constantly talk about POCs. Companies come in and say, oh, let's do a POC. Companies say to vendors, I'm sure DataRobot's probably hearing this 20 times a day, why don't you come in and do a POC? I'm allergic to POCs. I tell people, I don't care about POCs. I care about deployments. So what's a POC, right? Most of the time, POC does not stand for proof of concept. I know that's what you think it means. But the concept is typically proven 100 times over. Go look it up on LinkedIn. That's the proof of concept. You're done. A POC actually, most of the time, means a proof of competency, right? Does the vendor know what they're doing? Can I trust this guy? That's what it really is all about. And those are a lot easier to do. That's like a job interview, yeah. If you're clear and honest with people that really, I don't need to prove the science anymore, I just want to know whether you're lying to me, that you can do very quickly and be open about that, and you can move on, because honestly, nobody cares about that. We really want that agent to go live. And so having a portrayal like this is helpful. Now, again, if you're looking at the entire enterprise, what you really want to do is you want to come up with an enterprise-wide strategy. For us, again, we have hundreds of these agents in the making and hundreds more to come. And I'm looking for deployments. So am I going to build an agent from scratch all the way through the deployment and then build a second agent all the way from scratch to the deployment. I'll never get done. What I need is an enterprise strategy to knock them out one by one very quickly. And so that's, of course, why we're partnering with DataRobot to do this, to have an enterprise-grade platform that can do it all, one-shop stop, to make them and deploy them in one place, to have the infrastructure in place to get all of them not only scientifically, mathematically created, but then also shipped out to our users. And so you can see a typical chart at the very bottom. We have a data lakehouse in the cloud where all of our data lives. It's pretty complicated, again, because we're a physical business, so we have data from all sorts of systems. It's very, very distributed, between North America and the Middle East. We are in lots of places. On top of that, then, is the DataRobot platform, the orchestration platform that allows us to, from the data lakehouse, go fly fishing, get the right piece of data out of it, analyze it, train the various models, get them hooked up into agents, package all of that up. And then we've decided that we have multiple technological streams, all the way from the right as computer vision. That's our biggest one, where we have cameras in the field live streaming their video footage through the agents, all the way, of course, to enterprise search LLM models. All of that's being deployed and then ultimately, of course, monitored with an observability approach and shipped out. And that's how we look at getting to operational excellence, not just in one case, but in a whole collection of them. Now, I'm sure that many of you have encountered situations where there was a bit of miscommunication, and that was my leading cause of death number 3, right? You're solving a problem nobody has. It's a frequent experience, not only in AI, but in software development. And people have been drawing a chart like this for before the internet existed. So this is kind of nobody's intellectual property. But there's a huge difference between what the customer, the end user actually needs, which is the bottom right-hand picture, and how the customer explains it to you, the development team, which is the top left picture, and then all hell breaks loose in the middle. So again, the conversation between the people making the agent and the people using the agent is the critical element in all of this. And that's why, of course, you don't just need the scientific components to it, but all of the interactive components, which obviously the DataRobot platform provides to you, to be able to work together as a team of people, communicate with each other with extreme clarity to define what it is that you want this poor agent to do for you. And then you might be familiar with the John Fisher change curve, which basically displays the psychological reaction of a person exposed to something new. We all hate change, we know that, right? And if you propose a certain change, like adopt this agent, to people, they will react in various ways that you don't want them and you need to manage that. Again, that comes back to our 3 leading causes of death, right? The first one, the major one, says users say no thanks. They say no thanks because they're afraid. They are anxious. They don't know how to handle that. And of course, in AI, the biggest number 1 fear is that they will lose their jobs. And so we all need to make very clear AI is not in the business of layoffs. I'm telling you right now, if your business case is that you will remove a couple of salaries, it's not worth it. If your business case is that you will make people more efficient by 20 minutes a day, forget about it right there. It's not going to pay the bills. The real use cases, the ones that are actually worth it, make a material difference to your business. Right? Again, the example of ordering flour and butter for that bakery is a perfect example of that, right? We're not making a person slightly more efficient by 20 minutes in their day. No, we're making sure a material problem is solved. You running out of flour on an important day, right? That's the impact. And it's good to think about it in that fashion. At the end of the road, you're making decisions. Either you, the human, are making decisions, or you're getting the agent to make a decision on your behalf. Again, ordering something for your factory. And we're doing that. And so one of the examples that always comes up for an asset-heavy business is maintenance. We have a lot of pieces of equipment in the field, like pumps, turbines, compressors. They fail. That produces all sorts of problems. Not only do we have to then, buy a part and go out there and repair it and stuff, but of course the operation is in a shutdown mode during that time. We might spill some oil on the ground, right? That's really bad. So we want to prevent that as much as possible. So we've got multiple things in place. Agents that will forecast events, so that would be a machine learning agent, right? We have agents looking at camera footage to detect what's going on and so on. So by the by, not all agents are using LLMs. In fact, for us, the vast majority of agents are not LLMs. They're classic machine learning, computer vision type methods. But then the outcome is, so this thing just told me that next Tuesday, that pump, which is sitting somewhere in West Texas, is going to fail. Now what? And now you have to think through, or I'm advertising to you to think through a decision tree. There's this very simple example on the chart here, where you're thinking through, what are you going to do? So I don't have time to go through each branch in detail, but are you going to turn that thing off and then go and repair it and then turn it back on again and kind of hope for the best? Or are you going to let it run and hope for the best, right? Which track are you going down? In what circumstances are you going down which track? What are the outcomes if you do this versus that? And so you need to keep that in mind. And again, I'm encouraging you to think through the decision process at the very front before you create any agents, so that you're aware of what are the different scenarios that you're getting yourself into when you've actually got the agent. What are the good outcomes? What are the bad outcomes? And that will inform you much, much better about how you need to build the agent in the first place. So we've seen that be very important. If we, for example, and we did this, right? If you create a predictive agent first and then think through the decision mechanism later, you'll get no adoption. Because it's at that last stage where the end user will be like, oh my goodness, I'm going to have to actually do things when these AI people tell me stuff. And then things become difficult. So if you have the discussion about what you need to actually do in the physical world at the very beginning, super helpful for adoption of your agent on that day 90. So if you're interested in hearing more of what I have to say, I wrote down some of this stuff, so you can order my book. It's coming out in February, so it's not in print just yet, but possibility to get some bedtime reading. Thank you very much.